Meeting. Okay. All right, guys, it's recording. So good morning, everyone. We're going to go ahead and begin now. Friendly reminder, 9.1 is due today. So in your notebook, go ahead and write out Pascal's triangle. About 7 rows is perfectly fine. So let's go ahead and begin. All right, so I'm going to give you a couple seconds. You should have written this down since I did post it yesterday, but this is what we're looking at right now. So if I give you this information, we're going to go ahead and find some patterns. For some of us, we already know this, but it's always good to review. So if I gave you a plus b to some exponent, let's call it n. Here we have when n is equal to 4 and n is equal to 5. We have this so far. And we're going to go ahead and notice some stuff. Alrighty. So if you go ahead and notice how many terms are in the expansion. So let's look at the first one. When n is equal to 4, I got 1 term, 2 terms, 3 terms, 4 terms, 5 terms. So there's 5 terms right here. When the n is equal to 5, I have 1 term, 2 term, 3 term, 4 term, 5 term, and 6 term. So always when they ask you how many terms are there in an expansion, it is always n plus 1 terms. So we notice right here we had 5 terms because we added a 1 to the 4. We had 6 terms because we added a 1 to the exponent, which was 5. Another thing I want you to notice is whenever the exponent to the first part, so let's say a right here, what is happening to the exponent of a as you go to the right? So a to the third, a to the second, a to the first, a to the 0. And that happened to anything here. So it decreases by 1. Hopefully you already know that. The other thing that I want to stamp with you guys is what happens to the exponent of b from left to right. So from left to right, my b is right here. And hopefully you guys can see that it is increasing by 1. And you guys can see it in both. It doesn't matter which one you do, b to the second, b to the third, and b to the fourth. So we can see that it's increasing. If you pick a random term, what happens with the exponent? So let's look at, I don't know, let's look at this term right here. What is happening to the exponents? Well, let's look at that. We got this term right here. We have a to have 1 exponent, the b to have a 3. If I add those together, guys, you should have always n. So exponent of the a term and the exponent of the b term equals to the n, which is the n right here. No matter what you do, guys, so let's go ahead and pick another random one. Let's think of this one right here. A to the 4th plus b to the 1st. If I add them together, I get the 5 right here. That always, always, always happens. Okay. I'll wait a little bit in case someone needs to write that down. Okay. Okay. Other than that, guys, I'm going to go ahead and continue. And we're going to learn about today's lesson. Okay, so hopefully you guys can see that if I asked you a plus b to the 78th power, that's not going to be fun. Like, that's going to be a real pain to do. So what I'm going to go ahead and teach you today is how to find specific terms of very, very different ends of the exponent. So what I need you to know is that we're going to break stuff down into n components and r components. So n is this one right here, and r is the elements. So pretty much this is what you need to go ahead and write down. This is for today's notes. So in Pascal's triangle, we can break stuff down into rows, right? Remember rows start with 0. And the elements are these right here. You know? So this is what we're going to go ahead and do. So go ahead and write this down if you haven't already done so, since I did upload it in the notes yesterday. And this is the equation we're going to go ahead and use, guys. It's pretty dang cool. And then we'll go ahead and do some examples. And you can see it's not that bad. Alrighty, guys. This equation will be on the next slide. In case you need it, it'll be on the next slide as well. Okay, so let's go ahead and try it. So hopefully you see this exclamation point right here. If this would have been normal class, I would have yelled it out like, what is this right here? So I would have been 4 and shouted it out. But some of us are in hearing through earbuds, so that's gonna hurt your ears. So I'm not gonna do that. So 4 and it's called factorial. So this is from algebra 2, but I'm just gonna review it real quick just in case. So whenever we have this 4 with an exclamation point, does not mean shout it out. It means you're gonna go ahead and multiply each term until you get to 1. Until you get to 1. So example here, example 4. That means 4 times 3 times 2 times 1. And whatever that equals to, we can go ahead and find it. That is what a factorial does. So let's go ahead and find that solution. And I got, what is this? 4 times 3, that is 12, times 24. 2, that it would be 24. Thank you. That is what a factorial does. So for the next one, let's go ahead and expand 9 factorial. That is 9 times 3. Whoops, daisy. What did I do? Ignore that. Just kidding, completely. Wow. Technical difficulties. 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. That is what a factorial of 9 factorial would look like, right? Each term until you get to the 1. Okay, so a fun fact, go ahead and write this out in your notes. This right here, whenever you have a factorial of 0, that one, guys, it is equal to 1. Now, if in class, I would have showed you the proof for it, but unfortunately, I don't want to spend that much time. I'll post a link in case you want to know why. But pretty much, that is a factorial of 0. Okay, so a factorial just means multiply each term till the first term, until you get to 1. Okay, let's go ahead and continue. Alrighty, so whenever you see something like this, 5th row, 2nd element, you should automatically be thinking of 5th row, 2nd element. This is also seen as 5th row, 2nd element. This is these right here. So let's go ahead and practice this. These are used to see in combinations. So how many different ways? So for us that are going to be going into stats, pretty much if you have 5, I don't know, like 5 parking spots and 2 cars, how many different combinations can you do in parking that car in those spots? That's how this works. instead of how actually, doing the actual stuff. So they could either write it in 5 rows, 2 elements, or they can say how many different ways can 5 cars park in, I'm sorry, 5 parking, how 2 cars park in 5 parking lots, or these right here. So what we're gonna go ahead and see is that this is the same thing as saying N R. So let's go ahead and check our solution. So it's gonna be N, according to this N, is N goes on top. So according to this, my N is this term right here, the 5. So it's 5 factorial divided by my denominator, which says it is, 5 minus my R. My R is this one right here. So it's gonna be 2 factorial, don't forget the factorial, 2 factorial, okay? So before I start expanding my factorial out, I'm gonna go ahead and simplify inside here, this 5 minus this 2. Hopefully you see that that is 5 factorial over 3 factorial times 2 factorial. And before you start simplifying, guys, just write them out. It's because a lot of the stuff cancels. 5, 4, 3, 2, and 1 divided by 3, 2, 1 times 2 and 1. So hopefully you're able to see that this 3, 2, 1 and this 3, 2, 1, go ahead and simplify. So we're left with 5 times 4 divided by 2 times 1. So we can simplify that pretty good. That is 5 times 4, that is 20, divided by 2, that is 10. That is our answer. So if you were to actually try it, if we got 5 different parking lots and 2 different cars, how differently can you park them? It would have been 10. Okay, this right here is what we have. Any questions, or can I continue? Okay, I do have another example, guys. Let's go ahead and try it. 6 row, third element. So if we had a bookshelf that holds 6 books and 3 different books, how many different ways can you make it? That's the same way that it would be 6 and 3. Yes, we can use the table here. We can go ahead and find the 6th row and the third element as well. That works too. So it's gonna be 6 factorial, right? Because this is the same thing as saying 6 and 3. So that means there should be a 6 in the end, right? And a 3 here. So it's 6 divided by 6 minus 3 factorial times 3 factorial. All I'm doing, guys, is I'm subbing it into this equation right here. In the exam, guys, this was given to you, so you don't have to memorize it. But in statistics, I believe they don't give it to you. Okay, so simplify this 6 factorial divided by 6 minus 3. That is just 3 factorial. And this is times 3 factorial. So I can go ahead and write this out. So it's 6 times 5 times 3. Oops, what am I doing? Times 4 times 3 times 2 times 1 divided by 3 times 2 times 1 times 3 times 2 times 1. The reason I wrote it twice is because I had this one right here, right? So this one's right here. So that's why I wrote it twice. So I can go ahead and simplify 3 to 1, 3 to 1. Those are the same. I'm going to get rid of them. And hopefully you can see that 3 times 2 is the same thing as 6, right? So I got 5 times 4, which should only give me 5 times 4 divided by 1. That is 20 as my solution. So that is the first part of the lesson. So understanding how to use this, right? That's ideally you should be good. Is there any other questions from the first part of the lesson? If not, guys, you can ask the questions in the chat and I'll read through them in case you don't want to unmute yourself. Are we good? Okay. Alrighty, the next part of the lesson is this right here. So I'll give you a whole minute to go ahead and write this down. This is how to find a specific term. So if I told you, hey guys, I want to know what is the third term in a plus b to the 172 power, some of you guys wouldn't be like, heck no, I'll get this question wrong or whatever. But guys, there's an easy way to do this, and it is this equation right here. So the reason I was making you guys do this part right here is because it is essential into finding the solution. So the only thing you need to know is that n is the exponent. N is the exponent that goes right here. And r is found whatever term they give you. If they ask you a third term, then you just subtract the 1 from it, and that is your r. Okay, so that's how the r comes from. So I'll give you a couple seconds to write this down. And the same equation, guys, will be on the next slide in case you need it. So this lesson isn't that bad, and we should be starting calculus in the next unit. So I only have about 2 more lessons, and we're starting on calculus. That's what we're going to do right now. We're going to find a specific term. So we're going to use this equation to find a specific term. Depending what they ask you, they find the 5th term. Well, we subtract a 1 and we get the r. And then the exponent will be whatever they give us. Okay, this same information is on the next slide. So in case you didn't finish copying it, it'll be right there. Okay, so we're going to start off easy. So a plus b to the 5th power. We want to find the 3rd term. So somehow this right here will be my n. Remember, a plus b to the n. In this case, n is this 5 right here, right? So I'm going to go ahead and fill everything in. So it'll be 5 because this x1 is right here. Okay, and how do I find my r? Well, it is whatever term they gave you, you subtract a 1. So my r in this case is 3 minus 1. That will give me my r. In this case, r is 2. So this r is 2. And all I have to do now is fill in this. So I got my 5, I got my 2. This is the same thing as saying n and r, right? And I fill this in. So let me go ahead and write it in black. A n minus r br, where this is my n, right? And this is my r. So let's go ahead and fill this in. I got 5, 2. My a term did not change because my a term is still a. So it's going to be a. My n minus my r is going to be my n is 5. 5 minus 2. And my b is just my r, which is the 2. So let me go ahead and write over here. This is 5, 2. A, 5 minus 2, that is 3. And b to the 2nd. Okay. So all we're missing now, guys, is to find the combination of 5 and 2. So 5 and 2, how do we find that? Well, that's what we just did right here.
The other equation.
Yep, the other equation. So it says 5 factorial divided by 5 minus 2 factorial. Don't forget the factorial. And 2 factorial. So not that bad. We just write it out. This is, let me pick a different marker. That is 5 factorial. 5 minus 2. That is 3 factorial times 2 factorial. All we have to do next is write everything out. 5 times 4 times 3 times 2 times 1 divided by 3 times 2. Oops, that's a little messy. which is the same thing as in the denominator, 3 times 2 times 1. And don't forget this part right here, 2 times 1. So let's go ahead and start eliminating stuff because we know a lot of this. What's my marker? A lot of this is the same. So 3, 2, 1, right? This is a 1. It's the same thing as this 3, 2, 1. So I can get rid of them. So I got 5 times 4 divided by 2 times 1. That is 20 divided by 2.
Over 2
which is
equals
10.
10.
So my answer should be 10, right? Because this right here gave me 10. A to the third, B to the second. Okay, any questions on that, guys? That is your answer.
That's cool.
Yeah, so instead of doing, I mean, I'm pretty sure some of you guys can do this to the fifth, make your Pascal's triangle, do all the 1, 1, 1s, and all that good stuff. This actually saves you a lot of the work, but I kid you not, last year kids would still do it the long way, even though I taught them this because they like this a lot better. It was a lot easier for them. I'll wait a couple seconds so you can write this down. This will also be posted on the PowerPoint.
Wait, is this already calculus?
It is slightly calculus. It's still in the middle. It'll be trigonometry. I know we don't teach that class, that course here, but it's mostly trigonometry.
I have a question real quick.
Yes.
For the, when you have like the 5, is that a factorial, like the exclamation mark?
5, you mean this one right here?
Yeah, the green.
Yes, that is a
I'm going
factorial.
to say, okay, 5 factorial over 5 minus 2. Where did you get the 5 minus 2?
I don't have my dog here.
So sorry, I clicked the wrong button. So I got the 5 minus 2 from this equation right here. 5 minus my r, and my r was, remember this r, where my n, and this is my r. So I'm just following this equation.
I'm gonna have my dog here. She wants to be here.
Thank you.
Yep, awesome. Any other questions, guys?
Can I have my dog here really quick? Because she wants to be here.
Yep.
Okay, thank you.
All right. Any questions, guys?
No.
If not, the chat box is also open, guys. You guys can ask questions there, and I'll try to see them as fast as I can. This is my last example, guys. So if you have questions, please ask them. Okay, so I'll give you a couple seconds so you guys can get ahead of me, and we're gonna find the 8th term, given that the exponent is 10. So the first thing I like to do is find what is my n and find what is my r. So I can substitute them back into the equation. So hopefully you can see that my n is this 10 right here, right? So n is equal to 10. My r is the one that tricks a lot of people because I want to find the 8th term, right? The 8th term. But what is something you have to do to this r? You need to subtract. By 1. Yeah, subtract it by 1. That gives you the r. So the r in this case is 7. So all I have to do now is in this equation, substitute these numbers into my equation. So it's going to be n, which is 10, r, which is 7, a to the n minus r, and b to the r. Sorry, I should have substituted. You're right. So it's 10, 7. A is 10 minus 7, and B is to the 7. Let's go ahead and simplify. 10 to the 7. A to the third, yes, 10 minus 7 is 3. And B to the 7th. So far, so good, guys. Now this part right here, the 10, 7. That is back to this equation right here. They're asking us 10, 7. So all we have to do, guys, is substitute. So it's going to be 10 factorial divided by 10 minus 7 factorial, don't forget, and 7 factorial. Okay, not that bad. This is the same thing as saying 10 factorial over 3 factorial, right? Because 10 minus 7 is 3. And then this is 7 factorial. This is the same thing as saying 10 times 8, 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Whoa, that was long. And then we got 3 times 2 times 1 from the denominator. And the 7 factorial, 7 times 6 times 5 times we get the idea, right? Because this right here, right, would be 4, 3, 2, 1. So hopefully you can see that these numbers and these numbers are the same on top, same in the bottom, they equal to 1. Okay, so far so good.
So 120.
Yep. So this right here, we can go ahead and simplify. This 3 reduces with 9, so it's going to be 10 times 3, and this 8 reduces with the 2. That is what, 4? So this is 12 times 10, which gives me 120. And I go ahead and put this solution back into here. Give me a second. Let me finish this real quick and then I'll answer your question, Carlos. So let's finish this off. So our solution should be, you go ahead and write it in purple. Our answer should be 120, a to the third, b to the seventh. That should be your answer. This is your solution. Sorry.
Oh, that's kind of cool.
This is our answer.
Let's
Any
see.
questions, guys? And then I'll answer the questions in the chat box. So if they told you, hey, expand this to the 10th term and then find the 10th exponent in the 8th term, notice how easy that was compared to doing Pascal's triangle to a 10th exponent. And then the 8th term, that's a lot of work compared to how fast this is. Alrighty, I did have a question in the chat box. Let me go ahead and fix that, Carlos. I'm not too sure. I'll go ahead and fix it real quick. This should not be the same. I'll probably screenshotted something else. Okay, any other questions, guys? Okay, so before we begin, let's, before I let you guys go, I'm gonna go ahead and show you guys what if this was asking you a plus, I don't know, 2 or something to the 7th power. Now it's not b anymore, right? Like it normally is, a plus b. Let's say it was a 2. Well, keep in mind that 2, will, whatever happened to that b, if it had an exponent, so b to the 5th, now it is 2 to the 5th. So it doesn't always have to be an a plus b, guys, okay? I did it to be easy, but in the homework, it will have a...
Sorry, I have a question.
Yes.
On the bottom, like where the light blue is,
Okay.
I can't see like the numbers because like the thing on the bottom. So I don't know what you were doing when you were multiplying 10 times 3 times 4.
Oh, yes. So this right here, this right here, I just started simplifying. I did 10 times 9 times 8, but I noticed that the 9 and the 3 simplify. So 9 divided by 3 gave me 3. And the 8 divided by 2 gave me the 4.
Oh, okay.
I remember
To make it easier for my multiplying, because I don't know what 9
Yeah.
times 8 is, you know?
Okay.
And then I
got
just
it.
simplified it. 3 times 4 gave me 12. And then 10 times 12 gave me 120. But if you would have done, what is it? 10 times 9 times 8, you know, that would have still given you what? 720? No, that's not. I don't know. Divided by 6. See, you're really testing me here. This 120.
Yeah,
I'm assuming. Yeah, so I just do this because my brain cannot do math, you know.
Okay, thank you.
Yes.
Sir.
Yes.
Do you think you can do an example where it's not a plus b, or it's like a plus?
Sure. Let's go ahead and do an easier one because I'm not going to do the 10. It's going to be a little tough. But let's do this one right here. But that is a great question. Go ahead and erase. So very, very similar. So I'll do 2 because any exponent to the second is pretty easy. To the 5th power looks good. Yeah.
My dog fell asleep.
And let's find the term. 4th term. Is that fine with everyone?
Yeah.
Yes, no? Okay, so pretty much I do the same thing. I need to find my n, my r, because my a gets my n minus the r, and my b just gets the r. Yes, this is the equation. And the first thing I like to do is I like to find my n. What is my n? Well, it's not that bad. That one's always the exponent, right? So I have 5, and then my r is whatever term they gave me, I just subtract a 1, right? So it's going to be 4 minus 1. That gave me a 3.
Yes,
So far, so good?
Oh, wait, never mind. Yeah.
Okay, now I'm going to start substituting everything. My a is still a. So it's going to be a, my 5 minus my 3. However, instead of having a b now, I have a 2. So this is going to be 2, right? To the r power, so which is 3. Yes? Did I lose anyone?
No, it's fine.
Okay.
Yeah, it's good.
So it's going to be 5, 3, a to the 2nd, and b to the 3rd. So the 2 to the 3rd, which is the same thing as saying 2 times 2 times 2, which is 4 times 2, which is 8. So far, so good. Okay. The last but not least is this right here, the combination. But we know how to do that, 5, 3 by now, hopefully. This is 5 factorial divided by 5 minus 3 factorial, and then 3 factorial.
Yes, sir.
Yes.
So, and it's always going to be bigger than r.
Yes.
Okay.
Yeah. So I got 2 factorial times 3 factorial. This is going to be messy. I didn't run out of space. Hopefully I could do it here. So it's 5 times 4 times 3 times 2 times 1 divided by 2 times 1 times 3 times 2 times 1. And I got the same number also on top, 3 to 1, 3 to 1, and I can get rid of them. So I'm left with, it's gonna be 20 divided by 2, which is 10. So this right here is equal to 10. This right here is equal to 10, which means this right here is equal to 10, which is a to the 2nd times 8. However, I have like terms here, guys. I got a 10 and I got an 8. So I can combine those together. What is 8 times 10?
80.
Mm-hmm.
Oh,
And
that's cool.
that is your solution. That is your answer. Any questions on that, guys?
Thank you, sir.
Yeah, so one very, very similar to this one, guys. I picked a 2 because I don't want you to use calculator, but if you have to, I mean, I'm not going to stop you from using it. I just prefer that, I mean, 2's to exponents, you should be okay with that. 3's to exponents, you should be fine with that. So that is the only thing I did not mention, but that was a great question, guys. I think Carlos and Oram asked that. Other than that, guys, that is all that I have for you. Starting next week, we begin calculus. So we're going to be finishing sequences Wednesday, and then Monday we should start calculus. And that's all that's everything I have, guys. Unless someone has a question, then.
All right, sir, I'm a dip.
Okay, sounds good, guys. The homework is due on April 8th, so on Thursday. Feel free to ask questions. Carlos, I don't have info about the final exam yet, but I will get to you as soon as I have that. that is beyond me right now. I don't know, or I don't even know how that will happen because plagiarism and whatnot.
My dog just heard y'all's voices and just came over here. Now she doesn't want to leave.
Okay. Other than that, guys, you're free to go if you don't have questions. I'm gonna go ahead and stop recording unless someone has a questions. Stop
No,
recording.